Hello everyone, it's Mr. Pouts here, and this is a video for section 1.3, so chapter 1, section 3A. So this is going to be our first part of section 1.3. Tomorrow we'll watch the video for the second section of 1.3, breaking it up into two different sections. So it's entitled Real Numbers in the Number Line, and your goal to write down for today is right here. I can find and estimate square roots and cube roots. Okay, we're going to focus especially on the square roots part. I'm going to try and keep it quick. I know videos can drag on, but here's our keywords for today. We've got square root, and then with that we're going to have radical, radicand, and perfect square, and then the last one is cube root. Okay, very similar, but just slightly different than square roots. So make sure that goal is written down, self-assess yourself, and let's start taking some quality notes here. All right, wanted to start off with this little warm-up, this example here, and I'll actually block everything else off. It says if the pattern continues, which will be the first figure to contain more than 1 or 200 squares? Now we don't have to figure out the exact answer right now. I just wanted you to start thinking about patterns. And if you look, these are squares. So how do you find the area of a square? Well, you multiply one side by the another side, and those will be the same numbers. So this is a 1 by 1 square. So 1 times 1 is 1 times 1, or 1 squared equals 1. Here it's, whoops. The second one is a 2 by 2 square. So we're going to do 2 squared, 2 times 2. And there's a total of, whoops, I'm going to get rid of that whole thing there. So it's a 2 by 2, so it's 2 squared, or 2 times 2, and that's going to be equal to 4. So the area of that square is 4. So if it's a 2 by 2, it's going to make 4 of them. You can probably guess if it's a 3 by 3, you do 3 squared. And that's going to be 9. We have 9 squares there. You can add them up. And this last one, we've got 4 squared, or 4 times 4, and that's 16. My hope is that you remember doing this a little bit with exponents. I know we reviewed exponents in the last section, and exponents like this with an exponent of 2, the opposite of that, going backwards, is what we're going to be talking about today. Square roots is actually the opposite. So it says right here, the diagrams in the solve it above model what happens when you multiply a number by itself to form a product. When you do this, the original number, or in this, the first one we had 1 was our original number, second one was 2, 3, 4. That is called the square root of whatever the product is. So let's explain that a little bit further here. A number A, that's just a variable. Well, I'm going to make note of that. When I say a number A, that's just any number. We don't know what it is right now. We're just saying any number, but we're using the variable A. Is the square root of a number B, so there's another variable, if A squared equals B. So let's look at an example. What does that actually mean? It's kind of confusing to me. Might be confusing to you as well. So example, 7 squared equals 49. So we're going to use this symbol to go backwards. And 7 is the square root of 49. So the square root of 49 is displayed like this, you might remember, using the square root symbol. And the answer is 7. The square root of 49 is 7 because if you multiply 7 by itself, it'll get you to 49. Okay? So we'll do some examples with this in just a moment. But I want to show you a couple other things. Just to get so you understand what is what. That little symbol above the 49, it kind of looks like a division symbol when you're doing long division, but it's got that extra little tail there. It says that's called a radical symbol. A radical symbol looks like that. That indicates that you're taking the square root of something as long as it's not negative. And the expression underneath that radical symbol is called the radicand. So right now we have the radical symbol. So if we're looking right here, the red letters, and that symbol is called the radical symbol, and the thing underneath it is called a radicand. And together, those two things form a whole radical. So if we're looking at square roots, we're talking about radicals. I know it sounds kind of radical, but no, that's the mathematical term for it. So if you ever hear radical, you can think of square roots or cube roots. We're going to do as well. Just wanted to introduce that to you. So let's just do a couple examples to see what we know. First of all, I'm going to show you a couple with the answer, and then you're going to have a chance to do some on your own. What is a simplified form of each expression? So the square root of 81, I should have told you it already, but it is 9. And that is displayed here because 9 squared would get you to 41. 9 times 9 is 40, or 81, sorry. So 9 is the square root of 81. Okay, next one is the square root of, ooh, I'm going to add one in here though. Let's do square root of 49. Square root of 49 is actually equal to 7. You might remember that. Because if you do 7 times itself, 7 squared, that would get you to 49. So the square root of 49 is saying what number multiplied by itself would get to 49, and that number is 7. Some of these you just should have memorized. Some of these, hopefully seeing them, you'll remember a little bit better. Now here's one with a fraction. We're going to do a lot of these, but I wanted to show you the square root of 9 over 16 is equal to 3/4. Because I'll write it over here. If you want to figure out, again, we want to figure out what number times itself will get you to 9 over 16. And 3 over 4 actually does. Remember, we multiply straight across when we do multiplying fractions. 3 times 3 is 9. 4 times 4 is 16. So the square root of 9/16 is 3/4. Okay? Okay, I'm going to give you a couple examples here to do on your own. So if you want to pause it and try to work these out, see what you remember. I'm going to ask you one in a question here just in a moment. So there you go. A, B, and C, and D. A is the square root of 64. B is the square root of 25. C, what's the square root of 136? And D, what's the square root of 81 over 121? Okay, go. All right, we're back. So what is the square root of 64? Well, the square root of 64, figure out what times itself equals 64. And if you remember, 8 times 8 equals 64, or 8 squared equals 64. So, whoa. So, the square root of 64 equals 8. So this next one, what times what equals 25? Well, let's see, 5 squared, I think, is 25. So the square root of 25 is 5. All right, this one is a little bit trickier because it's a fraction, but it kind of boils down to what times what would get you to 1 and what times what would get you to 36. So really fractions, you're just doing 2 square roots in 1. So we can actually break it down like that. Do purple here. Instead of doing the square root of 1 over 36, you can say it's the square root of 1 over the square root of 36. And hopefully you know those. 1 times 1 gets you to 1. So that's 1. And what times what gets you to 36? I think it's 6. So the answer should be 1/6. Let's check that. 1/6. Let me check. Times 1/6. 1 times 1 is 1. 6 times 6 is 36. So that does get you to that 1/36. And lastly, we're going to do the same thing here. Let's just break it down by square root of 81 over the square root of 121. Because you're really doing the two different things. 9 times 9 gets you 81. So we got 9. And ooh, this is the harder one. If you remember, it's actually 11 times 11 to get you to 121. So your answer is 9 over 11. And let's check here. 9 over 11 times 9 over 11 equals, so that's 81 and then 121. So that would work. Okay? Make sure if you have questions on this, you write a question down and you bring it to class. We're going to be working on these the next day. I want to show you something called a perfect square now. I'll put this off right now. A perfect square. We're still talking about square roots, but so let's read this. The square of an integer is called a perfect square. So if you remember what integers are, we're going to talk about them more tomorrow. but those are just counting numbers. The square of an integer is called a perfect square. For example, 49 is a perfect square because the square root of 49 is a whole number. It's 7. It's an integer. But this is also important here. When the radicand is not a perfect square, your answer will not be a perfect or a whole number, so you can estimate the square root of the radicand. So let's just take a look at doing that real quick. See what that looks like. So here's a list of perfect squares that maybe you have memorized from back in the day. But so I don't know if I like this one so much, but kind of to put this into terms, this is going backwards. But if you go backwards, actually we'll do this here. The square root of 1 equals 1. Well, I'll actually write them over. Square root of 2 or 4 equals 2. That's because 2 squared equals 4. Square root of 9 equals 3. Square root of 16 equals 4. Square root of 25 equals 5. Whoop. Square root of 36 equals 6. And so on. If you notice a pattern here, I'm hoping you notice a pattern here, because every time you look over here, every time you square a number, so 2 squared gets you to 4, that means the square root of 4 is going to be equal to 2. All the way down to 10 squared, 10 times 10 is 100, so the square root of 100 is 10. Now, if I were to give you, let's say, we'll give you a few examples here. Square root of 50, square root of 10, square root of 90. None of these are on the perfect square chart. None of these are in here. So 90 would be like in the middle of here somewhere. So we're going to have to estimate. So not perfect squares, estimate. What it means to estimate is to kind of round to a thing that would be closest to it. And if we're taking the square root of 1 or square root of 50, let's see, this would go right above here. So an arrow. So right above there. So it's just going to be greater than 7, it looks like, but it's not going to be as high as 8. So just barely over 7. Let's estimate, and this means it's approximately equal to. Let's estimate 50. Or sorry, no. The square root of 50. So what times what will get you to 50? It's going to be just, let's say 7.1. That's an estimate because it's just greater than the square root of 49. And I'm going to just show you, for instance, if we do take, you can do square root on here. So I do 50 and square root. So it's 7.07. That's almost 7.1. So that was a good estimate. Next, let's try the square root of 10. See what it's close to. So that would kind of go right above, right here. So that's just barely above 9. So the square root of 9 is 3. So the square root of 10 would be maybe 3.1. It's definitely not as high as 4. So let's try this. Square root of 10, 3.16. So that's a pretty good estimate. We could say or 3.2. Now let's try the square root of 90. That's not going to be a perfect square, so we have to estimate. Looks like that's almost right in between these two. I'm sorry. It's almost right in between those two. So square root of 81 is 9, square root of 100 is 10. So why don't we go right between that and say 9.5 is going to be your answer. And if you check here, 90, and then I do a square root symbol, just under 9.5. Okay, so that's how you estimate. That's how you estimate square roots if they're not perfect squares. So I'll give you an example of that to do right now. Okay, let's go on to cube roots. Cube roots are slightly different. The only thing different we said here, these are variables. A number a is the square root of a number b. Sorry, cube root. If a cubed gets you to that b. So if you're trying to find the answer of a square root, that would mean that what number times itself would get you there. So for instance, square root or cube root, and it's listed like this. It looks just like a square root. And I'll highlight that. The only difference is that 3 right there. That means you're finding the cube root of 27. So the cube root of 27 is 3 because 3 times itself 3 times. 3 times 3 times 3 is 27. That's the difference between a square root and a cube root. Square root, you're just finding what number times itself gets you there. And a cube root, it's times what number times itself and times itself again gets you there. It's hard to explain, you just have to see more and more of them. Cube root of 8 would be 2. And hopefully you're catching on. It's because 2 cubed is 8. So 2 times 2 times 2 is equal to 8. This one up here was 3 times 3 is 9 times 3 is 27. Okay, let's do one more. Cube root of 1. I want you to try that on your own. What times itself will get you to 1? Hopefully that was an easy one for you. It is equal to 1 because 1 cubed equals 1. Now that's not 1 times 3. That's 1 times itself 3 times. And 1 times 1 times 1 is just equal to 1. Okay? So that's the intro to cube roots and square roots. Make sure if you have questions on this, and there is a slight difference between square roots and cube roots, make sure if you have questions on this, you bring them to class. We're going to do some practice with this, and hopefully you'll feel more comfortable doing this. All right, so that's our video, and until next time, we'll see you.